We have learned that arrays are passed to functions by reference only. We have a good understanding of how pass by reference works. In the last bit of the lecture on arrays and functions, we're going to talk about pass by reference in detail, and we're going to summarize the difference between pass by reference and pass by value. So in processing, functions, parameters are passed to functions by reference or by value. This is the same in other languages as well. Processing, pass by reference and pass by value work pretty much exactly the same as it works in Java. C++, it's a little bit different, so there is a bit of difference for pass by reference in C++ and in processing. So for those of you who go on to learn about C++, make a note of this, that pass by reference is a little bit different in C++. So let's look at how pass by reference works in processing and study the details of this. So in processing, all data types are passed by value to functions except arrays and objects. We have not discussed objects yet. We're going to briefly talk about objects. Of course, object-oriented programming is a huge field of study. We're not really going to get into it, but we're going to introduce a simplified version of objects in this course. So all data types, that means ints, doubles, chars, what have you, they're all passed to functions by value. That is, the function is going to receive a copy of what the arguments of the content of function arguments. But arrays and objects are only passed to functions by reference. So you cannot pass an integer to a function by reference. Integers are passed to functions only by value. Arrays are passed to functions only by reference. So you cannot pass an array to a function by value. So this is the main difference here. So again, just to let's talk about pass by value for a second. So if you have an int, a double, a float, they're all passed by value in processing, and there is no other way around it. This is basically the difference between processing and C++. In C++, you could pass an integer by reference too if you wanted to, but in processing you're not allowed to do that. So let's look at this function. So we have setup, we have var, and we are passing var, which is an integer. Content of var is going to be copied into x. So now the issue is that x, the value stored in var is going to be copied into x. X doesn't know where var is in memory, so it doesn't know in memory. So if you make any changes to x, that means that var is completely unchanged. So in other words, there is no link between var and x. So if you change x here, var is not changed at all. So when this function returns, we are back here. Var is still 10 in memory, and this is essentially passed by reference, passed by value. However, objects, as we explained, arrays and objects, we haven't talked about objects of course, but arrays can only be passed by reference. So if you have something like this, R is a reference to data. So in fact, R knows where data is stored in memory. So when you make changes to R, the data is going to change in setup in memory. So here we have data. So this is setup. Data is 12, 13, and 14. Indices 0, 1, and 2. When we call foo, foo is going to receive R, and R is a link between data and R. So there's a link. So when you say R index 0, that means this guy is going to change. So 12 is going to change to 100. Then you say R2 to 200. So R2, this guy, is going to change to 200. And then the function is done. When the function is done, this function is going to go off memory and the link exists no more. So data in memory now is 100, 13, and 200. So pass by reference, it's you can pass by reference means that, if I go back, means that R knows where data is in memory because there is a link between R and data, and the link is clear. Now this works perfectly unless the data reference link between R and data is broken. How could this be? How could you break the link between R and data? Well, essentially, when an array is passed to a function, it is passed by reference. So you can modify its elements. But you cannot assign it to a different array. You cannot assign new memory to it, because if you do that, the link would be broken. So let's look at an example here. Actually, let me just. So let's say we have, and you can program along with me. Let's say we can have void setup, and let's say we have an int. We call it data, and I'm going to put values 11, 12, and 13 in there, right? And let's say we have a function foo, so we'll just say void foo, and it's going to receive an array. So if we call function foo, and we pass data, if I said R index 0 equal 100, and then if I print data, and let's draw the memory diagram here. So in setup, we have data, which contains 11, 12, and 13. And here we have foo, and foo contains R, which is having a link between R and data. So if I said R is 0 equal 100, you see that in the first element, I'm going to get 100 right away. And if I run this, you can kind of see that now I have 100, 12, and 13. If I don't call foo, by the way, so if there is no foo, the array contains 11, 12, and 13. But if I call foo, sorry, I didn't call foo. If I call foo, then R has changed. Okay, well, this is great. So this function changes data because R is passed by reference. Now, what if I did something like this? If I said R is new int 4. What does this do? So I'm assigning R to a new array. So I am assigning R to a new array. So what happens is I'm going to say, okay, well, R is a reference is a reference to data, but when I do this, what ends up happening, the link actually gets broken because R has a new value now. So the value of R is going to be 0, 0, 0, 0. It's going to have an array like that. So if I do this, then you can see that the link has been broken. So for example, if I say R index 0 equal 100, now it says, okay, well, R index 0 is this guy, so this is gonna be 100. So when this function finishes, we go back to setup, let's run it. It hasn't changed at all, right? Because that's it's 11. The link has been broken, so we start off with data as 11, 12, and 13. We call foo, but foo here, in this line, we assign R to a new array. So the reference link is broken. Therefore, any changes made to R will not affect data in setup. Because there is no longer a link between data and R. So the link is broken in this case. So you cannot allocate new memory for the array using the new operator, and you cannot make changes to the array using array functions. So arrays like append, functions like append, function like sort, they do the same thing. Let's see. Actually, let's see an example of that. So, oh, excuse me. So I want this. I want this. So let's say we have this, and let me just take my notes off. And let's say in here, I say R equal append R 100. Let's see what that would do. So what this would do is we're going to have setup. In setup, we're going to have data. Data has 11, 12, and 13. And we're going to call foo. So when we call foo, we're going to get R passed in. R has a link to data. Then we're calling the append function. So what the append function does, actually, so it's a predefined function, but what actually happens is it's going to appear up here. So this is foo. Append is being called by foo, so we're going to get append here. And what append ends up getting is a copy of R, a reference to R. So it's a predefined function. So we don't know the name of the variable that they use inside, but it's going to have some array, and it's going to get a value. Don't forget, it's going to make an array, append 100 to the end of array, and then it's going to pass it by reference. So that's the most important part. So when append is done, it's going to pass the result of the append by reference, which means it's going to be copied into R, which means R is going to break its reference, because don't forget, R is actually catching the return value of append. So the return value of append, which is 11, 12, 13, and 100 is going to be stored in R. So let's do this. If you run this function, and if I want to know what is inside of R, I would just print what's inside of R. And you can see it's 11, 12, 13, and 100, just as we've shown it in memory. But when function foo terminates, because there is no link now between R and data, data has not changed at all in memory. So if I comment this out, if we go when function foo finishes, we go back to setup. You see that data hasn't changed at all because there was no link between R and data. The link was broken. So this is the return value. The return value of append is copied into R. This breaks the link between R and data. Therefore, when foo is done, data is unchanged back in setup. All right, so hopefully this is clear for everybody, and if you can understand this, if this is clear, that means you're doing really well.